about matrices is different, but almost everything about matrices is new. So you do need to make sure you're tuned in and you're paying attention.
Wait,
so that this makes sense. This is the lesson. Today we're going to look at solving matrix equations and then solving systems using matrices. Now, I'm going to show you some rudimentary, very simple problems. But let me go ahead and tell you, I would never use matrices to solve simple problems. The reason we use matrices is to solve the much more complex problems. But for you to be able to understand what's going on, we start with simple. Okay? So before I ever do it, please don't tell me I would never do it this way. Because I hope you would never do it this way. What I'm teaching you today is not the way you should do it. Okay, so first of all, let's talk about how we would solve a matrix equation. Okay, so here we have a 2 by 2 times, the capital X stands for matrix. A 2 by 2 times matrix X is equivalent to matrix B, this matrix. So we call this one A, this one X, this one B. Okay, so we want to solve for matrix X. Division by a matrix is not defined. So we can't just divide by A, because if we had like 2x equals 5, we would just divide by 2. But we can't do that in the world of matrices. So we need this to go away. Who thinks they have an idea of how to get rid of matrix A? What do you think?
Multiply by its inverse.
Multiply by its inverse. Okay? So I would like everyone to please find A inverse.
No.
All right, so let's do it. First thing we have to do is find the determinant of A. 10 minus 8 is 2. So this is 1/2 times, switch the main diagonal, change the signs of the other. Okay, distribute. So the inverse of A is 1, negative 1/2, negative 4.
Negative 5/2.
No, positive 5/2.
Positive. Never mind, I'm sorry. That was my fault.
It is positive. All right. So it's decided to quit working. I'm going to plug it in and see if it'll change its mind. All right, let me pause again, see if I can get this working. I know. Okay, so we took a time out to see if the Mobi would start working. We think it's working. We'll see. All right, so this is the matrix equation we're solving. Matrix A times X equals B. So you guys said that we need to multiply by the inverse to eliminate matrix A so that we just have X left here. So here, order does matter. So we're going to do A inverse here, so it's going to go in front here. So on this side, we're going to do A inverse times A. So we have 1, negative 4, negative 1/2, 5/2, times 5, 1, 8, 2, X, matrix X. And then we have, we're going to do the same thing over here. 3, 0, 1, 4. 1, negative 4, negative 1/2, 5/2. Okay, so just remember, this gives us 5 minus 4, 1. 2 minus 1, 0. Negative 20 plus 20, 0. Negative 4 plus 5, 1.
So we just need to remember that. We don't even have to like really do all the math.
Okay.
You have to know why. Like, don't.
Oh wait, never mind.
No, you need to find the inverse anyway. That's right.
All right. So now we have to do this multiplication. So guys, go ahead and do that 2 by 2 times that 2 by 2. It's pretty simple.
Alright.
Oh, so you don't have to do the math because you know it's going to come out to be ones down the side.
It might not though.
But it has to be if it's the inverse. It has to.
Okay, if you don't do this quickly in your head, you've negated your check step. So let's say you missed one thing right here. You would catch it when you did this multiplication, wouldn't you?
Yeah.
Well, you're right.
If you don't catch it, you could get the answer completely wrong.
And fail everything.
That's right, and fail everything.
That's why you don't take shortcuts, kids.
Unless you're tired.
Wait, how did you?
Like,
do that?
you have to take shortcuts.
I mean, we all can be perfect like you.
Oh,
Check your work, teacher. Check your work.
Wait, just want to say here now.
Everything else.
Matrices is on the ACT.
I'm taking the essay.
You didn't see matrices on your ACT?
I mean, I took it in like 7th grade.
Oh, yeah, it changed. Yeah. Okay, so we should have gotten 2.5.
Whoa, how?
Got that?
3, take away a half.
Oh, I multiplied it.
Can you write them as fractions? Do you care?
I don't care.
Okay. 10.
Okay, now, this right here we know gives us the identity. So what we're left with on this side is the identity times x equals, this gave me the answer part. Well, what do we know that the identity times any matrix is? It's just that matrix.
Yeah.
So to get the answer, x, matrix x is 2.5, -2, -9.5, and 10.
So can you not divide matrices?
You cannot.
That's what
So,
Wait a minute.
you said the identity matrix times anything is equal to itself?
The identity matrix times any other matrix
Multiplying by 1.
is just that matrix because it is like multiplying by 1.
But
Correct.
If you can multiply by the inverse, then isn't that divided? The same thing as dividing?
Nope, it's multiplying by the inverse.
Which is like dividing.
Okay, you can relate it to division of real numbers, but it's not the same operation. There is no division of matrices.
So if you took what we just got for x and multiplied it by a, you would get
And then the 1, 0, 0, 1.
that one.
If you did this, okay, so that's a good question. If we did a times x, will it equal b? Yes, if we did it right. But we have to do the order this way. A has to come first, x has to come second. Okay?
Okay.
All right, so now we're going to look at this. So let me erase all this again. All right,
Hey, remember, don't complain.
okay, I'm going to start giving detention for the outburst, the ridiculous outburst that some of you do when I put up simple problems. Because you are disrupting instruction, and the rest of us are not entertained. We are annoyed. So at this point, if you continue to have outburst before I've explained anything, you will receive detention because you're slowing down the class and you're irritating me. Okay. All right, so once again, before I started this lesson, I said there would be no way that I would ever choose to solve this type of system using matrices. This is so simple to do with elimination, we would never do it any other way. Okay, maybe some of you would choose substitution, but I wouldn't. I would just subtract, y's would go away, we'd have x, we'd be done. Okay? But I'm choosing something simple that you do understand what the answer is quickly, another way, so that you will know that this way works. Okay, so what we're going to do is we're going to take this system and we're going to represent it as a matrix equation. So what we're going to have is a coefficient matrix times a variable matrix equal to the answer part. All right, so let me show you what that looks like. So a coefficient matrix what would the coefficients here? We have a lot of understood ones in here. So when we do our coefficient matrix, it would look like this. We've got 1, 1, 2, 1. 1, 1, 2, 1. There's our coefficient matrix. Now we're going to multiply that by the variable matrix. Now, what are the variables? X and Y. Now I'm not just randomly setting this up. I'm setting it up in a way that if I did this product, it actually gives me this side of the equation. Do you see that if you do this product, 1 times x is 1x, 1 times y is 1y, so this would be x plus y. 2x plus y. So if we do the matrix multiplication with this 2 by 2 times this 2 by 1, it takes us right back to where we started. Now, we will set that equal to an answer matrix.
So you're just writing the whole thing down.
You're representing this system of equations as a matrix equation.
Why is the top x and the bottom y instead of the other way around?
Because if I do this multiplication, I need a 2x. So the 2 is multiplied times the x. And the 1 goes with the y. Remember when we do this row times this column? 2 times x plus 1 times y.
Oh, that makes sense.
Okay, cool. All right, so now we're going to use the same process that we did just solving a matrix equation, because that's what we've created. We've created a matrix equation. So if I consider this A, and this X, and this B, to solve this, I would multiply by A inverse. A inverse. Please find A inverse. Okay, so the determinant is 1 minus 2, which is negative 1. So it's 1 over negative 1. Switch these two. Well, they're the same. So when you switch them, it doesn't look any different. And change the signs of the other two. Then we distribute the negative. So A inverse is negative 1, 1 to negative 1. So that's what we will multiply by on both sides. So here we go. A inverse, negative 1, 1 to negative 1 times this. And I'm quickly doing that in my head to make sure I did not mess up.
So you're finding the determinant.
No, not that. I'm talking about individual.
Okay, to find the inverse, we switch these two. But then we change the signs of those two, okay?
Yep.
So that's where it came from.
You got yours.
I thought I was losing my mind.
Yeah, I thought.
All right, I am just double checking to make sure I haven't goofed anywhere. So I'll do this. 1 plus 2 is 1. Negative 1 and 1 is 0. 2 minus 2 is 0. 2 minus 1 is 1. Okay? So we did it right?
Yes.
And then do the other side.
Okay.
Okay? So what'd you guys get?
Negative 7 over 15.
You got negative 7
Over.
over 15. Okay, so when we do the identity times this just tells us that matrix, our variable matrix is equal to this. So if these are equivalent matrices, guys, what is the value of x? Negative 7. What is the value of y? 15. Well, that was a really long way to do something we could have done quickly.
But what if it was a 3 by 3?
That's why we like it. Because if we had a system of 3 equations with 3 unknowns, or 4 equations with 4 unknowns, or 5 with 5,
Then I would never do that.
then this is where matrices becomes extremely helpful.
That's actually really nice.
Okay? So, But you're probably thinking, Miss Willoughby, you did not show me how to find an inverse of a 3 by 3. You're right, because it's time to use our technology. Okay, so we're going to use the TI-84s.
We don't have to do this in calculus either. Like, we don't ever have to do this.
Matrices?
No, inverses.
No. It might show up on a math team thing, but I'm okay with us not getting it right.
Alright. I'm done.
Okay, so I want to see every time I must see you set up the matrix equation on your homework. Must. Okay? This time we have 3 variables. We have x, we have y, we have z. So if they're not ordered, if they're not all matching in order, that's the first thing you have to do is rearrange this system before you start setting up your matrices. Yes, ma'am. Okay, so I want the coefficient matrix here and basically the answer part here.
Wait.
Don't you say that. This is acceleration.
Okay. Oh,
I just confused my.
The last one's 3, -4, -1.
Huh? What? No, it's not that. I know.
All right, so coefficients, 1, 1, 1.
Yes.
3, -2, -1.
Oh wow, that's a lot simpler than I thought.
1, 1, -1.
Yeah, that's what.
Alright.
Okay?
Yep.
So, now, to solve this matrix equation, we need A inverse. We need A inverse here, and we need A inverse here, right? Okay, so what we're going to do is we're going to let our calculator do some of this work for us. Because we know to find the variable matrix, it's A inverse times B. So, we need an A inverse, we need a matrix B in our calculators. So go ahead and pull out your calculators. You see how I already have the answer here because I did it yesterday afternoon. But let's start together. All right, so you guys haven't entered matrices before, but they're under matrix. So, oh, you didn't stat. Never mind. So, okay, second and x1. All right. So this is where we enter matrices. Now, to actually change a matrix that's in there, you have to go over to edit. And since I'm using A and B, I'm going to use A and B. All right, so you hit enter. Now, yours may not say 3 by 3, but you can make it a 3 by 3. So do 3, enter, 3, enter. And now yours should match mine. Well, in dimensions. Now you would need to enter your coefficient matrix. Mine is already there because I did it yesterday. So go ahead and enter and make sure if it's a negative number, you use the negative down here, not the minus. The negative down here, not the minus.
So you just did wait. Which ones do we do again?
You enter the coefficient matrix for A
Okay.
and the answer part matrix for B.
Okay.
So is there not an inverse formula for 3 by 3s?
Yes.
There is?
Yes.
Are we
Do we
going
have to
Would you like to learn it?
Not really.
I'm not making anybody else.
Okay.
Oh, I see.
So this is how we're going to find the inverse.
Correct.
I'm not.
If it's a matrix that's greater than a 2 by 2, we're using technology.
Can you find the inverses of 2 by 1s?
It has to be a square matrix.
Do we not worry about 1 by 1s again?
1 by 1s isn't really a rectangular array, it's just 1.
Yeah.
Yeah.
So it's really just one variable, one individual. So there's no reason to even have a practice.
Alright. Let me know when you have A and B entered.
Oh, B, we
Got
have
it.
B.
So let me know when you're here and you've got A done and B done so we can move on.
Okay, I'm done with
That's just gonna
You're done with A? All right, go ahead and move on and do B.
Okay, just finish.
Okay. Does anybody need help?
Yeah.
What is, oh, 3 by 1. My dad's up. Wait, we're entering this, not the variables, right?
The coefficient matrix and the answer matrix. The A and the B, not the variables. Okay. Did I hit pause? No, I didn't. So we're recording. Okay, so now we're going to solve. So to solve, we said we needed A inverse times B. So I'm going to choose A. So when I go back in here, I don't go over to edit now. I just push 1 to choose A. But I don't want A. I want A inverse. Right here. A inverse.
Can you tell me how you did that again?
I pressed 1.
And then.
Okay? And then we go back in, and now we press 2 for B.
Okay, how did you? I pressed 1, but it didn't give me.
All right. Let's do it again. There's the answers, but I'll do it again. All right, so here we go. Those of you that struggled, if you hit second and matrix,
Yes.
A is already entered, so just press 1. And then inverse, right here. And then start over, second matrix, and now 2. And enter.
Oh.
Oh my god.
Is
Like a super big number.
I'm like,
Okay. So, we got a little too excited about that.
You love math now.
That was
Discovered math.
all right. So,
We discovered that we don't have to do it ourselves. I'm gonna go home and allocate for 2 by 2s also.
now we know X, Y, and Z, guys. We know X is 0, Y is 1, Z is 2. Okay, I'll come. All right. So,
So that finds the variable.
that's it for today's lesson, but I'm going to come